Hi, I'm going to introduce section 3.1, and it involves exponential functions. And I'm going to begin by asking you three questions and then providing you the answers. And what I'm trying to do here is to show how exponential functions can be used. Okay, first question. If I invest $2,400 in the stock market this year, and I get a rate of return at 10% per year, how much money will I have in 40 years? Just a couple of points. 10% is about the average rate of return in the stock market over the last 100 plus years. $2,400 in a year amounts to $200 a month, and that's a reasonable amount that an employer might put in a retirement account for you if you have a base salary of $50,000. So again, I want to give some context. Okay. Next question. The effective transmission rate, called R sub t, for COVID-19 in Iowa is 1.04. That means that on average, each infected person infects 1.04 people. That's what the transmission rate is right now. So, October 13. Now, on October 13, there were 1,080 new cases of CV in Iowa. How many people would these people infect in 6 transmission cycles? Now, one transmission cycle would be how many people these 1080 infect. 2 transmission cycles would be how many people the 180 infected would in turn affect, and so forth. Transmission cycle is between 4 and 5 days, so 6 cycles would be probably a little bit less than a month. Just some context. The RT value was 2 when Drake closed in March. It was 0.77 before reopening in late April. And it was 0.99 on August 22. Okay. One last question. Plutonium-239 is a radioactive substance that is used in nuclear power plants. 1 pound of plutonium-239 provides about the same amount of power as 15 tons of coal. However, it remains radioactive for a very long time. In fact, in 1 year, 1 pound of plutonium-239 would be about 99.997% as radioactive as it was the year before. That means it doesn't lose much of its potency over the year. So how long would it take 2 pounds of Pu-239 to lose half its potency? And by that, I mean to be as radioactive as 1 pound. Okay, let's answer the questions. Okay, the money question. The answer is 2,400 times 1.1 to the 40th power. That's a little bit over $108,000, about 45 times as much. Notice that 1.1 is 110%, which is what a 10% rate of return represents. Your money grows 10% per year means you have, if you take the money you had in 1 year and multiply it times 1.1, that's the new money you have. Okay. So the 40 comes from the years, the 240 is our initial value. One reason I bring this up is because when you invest money for any investment, let's say for retirement, your employer puts money in often, and what happens is that's really each year you're investing money. So that means that if you do this for your working cycle, you can save a lot of money. So if you start putting away money soon, you'll have a lot of money when you get to my age. Unfortunately, I didn't take my own advice. Now that's another story. Okay, the effective transmission rate. The formula is 1.04. So we took 180, multiplied it times 1.04. If I just did one of those, that would be how many people those 180 would infect in 1 cycle. But we want 6 cycles, so I put a power of 6 there. I did the computation, and it's about 1,366 people. The last one was the plutonium one. Okay, so I asked how long it would take 2 pounds to lose half its potency, and that means how long does it take 2 pounds to become 1 pound. So I took the 2, that was how many pounds I had. I took 0.99997, which is the percent decay expressed as a decimal, and I just played around. And first I tried this number, 23,104, and I got a little over 1 pound, and then I got 23,105, was a little under 1 pound. So those 2 pounds become half as effective in about 23,000 years. Okay, so it takes a long time. Okay. So here's the point. When an amount of something B, an initial value, grows or shrinks regularly by a particular percent per time period, Again, that rate is going to be A. After t time periods, the amount present is given by a function that looks exactly like this. Now, A is going to be the percent expressed as a decimal, and B is how much you start with. So, if money grows at 10% per year, then, here, let me fix this. Then this should be 1.1% right here. So let me mark that. That should be a 1 there. Okay. If money grows at 10% per year, your rate A is 1.1. F of t becomes B times A to t, however many years you're thinking about. Okay, here's the disease. 1.4 people get infected in a cycle. Then the function is how many people you start with, B, what the infection rate is to the t, and t is the time period. How many cycles we're doing. For the third example, we have the decay, which that's what happens if it's decreasing at a rate. That's called decay. Then that's my A right there. So here, let me mark that right there. 1.1 was my A here. 1.4 is my A here. Here my A was 1.1%. Remember to add that 1. We'll go over that. So in this last one, if it decays at this rate, that's my A. So I put that there. B was the 2 pounds that I started with. And T was the number of years. Okay, so we're going to go into this in more detail. Okay, so I will talk to you more in the next video.